All right, so today we're going to talk a little bit about significant figures. And sig figs are important usually when you get into mathematics in college. Physics class will use them and chemistry uses them. However, you're not going to be held to a high standard when using sig figs in high school versus college. But it's important to kind of go over the rules, and I have a little idea here that I read online that might help you. So the basic rules are all digits that are not zero are always significant. So if you have a number with a 1, 2, 3, 4, 5, 6, 7, 8, all the way up to 9, those are all significant numbers no matter where they're located. Okay, so 113 is 113, that's 3 sig figs automatically. 1.11, that's 3 ones, that's 3 sig figs. Right? They're all significant. The second rule is zeros that are trapped are also significant. So if there's zeros trapped between two numbers 1 through 9, 101, 101, that zero is significant. That's going to be 3 sig figs. Right? If the zero is not trapped and it's just a placeholder on the side, either before or after, so 0.001 would just be 1 sig fig because the zeros are not trapped. 100 is 1 sig fig because the zeros are not trapped. Right? However, there's a little bit of confusion with this one because if you put a decimal point, now they are considered significant. So any zero after a decimal is significant, and any zeros between a decimal and a significant number are also going to be significant. So 100 decimal point 0 is 4 sig figs. 100 decimal point is 3 sig figs. Okay, it's just letting us know that we did measure exactly to that number. Zeros in the beginning of a number whose only function is to place a decimal point are not significant. So like I said, 0.0025 or 0.0025 would only be 2 sig figs. However, 0.00470 would be 3 sig figs. That trailing zero, remember, after the decimal point or after the number counts. So it's very confusing. So I have a rule that I read that I think clarifies sig figs to the easiest possibility there is. If you know anything about geography, you know that the United States has the Pacific Ocean on one side and the Atlantic on the other side. And then we can say west and east, but let's just go with left and right. Right? So if I imagine a number 100.01, okay, I have my right side, which is on the decimal side. I have my left side, which is the whole number side. Okay. The Pacific Ocean, decimal point, PP. If there's a decimal point, we use the Pacific Ocean rule. So we go all the way to the left, and we work our way over until we find the first significant number. And now we know that every number after that is significant. So we just count them all the way to the right. So 100, 100.1, that's all 4 of them are significant. Okay, let's do a harder one. Let's do 0.040400. Okay, well, I start at the left. My first zero, not a significant number, decimal point 04, first sig fig. Now I count all of them. 40400, 5 sig figs. Okay, see how I did that? We just start from the left. First whole number we get to, 1, 2, 3, 4, 5, 6, 7, 8, 9, our first, whatever you want to call it, significant number. We just keep going. If there's no decimal point, the Atlantic Ocean is on the right side. We start from the right and work our way over. So let's say we have a number like 7,080. Well, go from the right. 0, 8. 8 is the first number I have, right? So 8, 0, 7. 3 sig figs, 7,080. That's all it is. Start from the left if there is the Pacific Ocean, decimal points involved. Start from the right if it's the Atlantic Ocean, no decimal point. And as soon as you get to that first 1, 2, 3, 4, 5, 6, 7, 8, or 9, is when you start counting. And every zero after that is going to count, right? Unless someone does something really crazy like write down 1000, which doesn't make any sense and no one's going to do that. Okay, but otherwise this rule works. Pacific Ocean, Atlantic Ocean, decimal point, no decimal point. Count from the left, count from the right. Good luck.